Alright, so Dr. Regal posted the syllabus. Congratulations, Dr. Regal, first to Awaken Blackboard. It's always nice to have this stuff up early. We have some readings, and school starts next Tuesday. So chapter 1.1 to 2, 1.6, and 2.1 to 3, and then some homework problems, 1.10, 125, and 128. So let's take a look. I don't think I can fast forward here straight to the problems, so let me scroll down. 125. Okay, so the first one, 1.10. 1.10 first is a freezer compartment consists of a cubical cavity that is 2 meters on a side. Assume the bottom to be perfectly insulated. What is the minimum thickness of styrofoam insulation? K equals 0.030 watts per minute Kelvin. That must be applied to the top and side walls to ensure the heat load of less than 500 watts when the inner and outer surfaces are -10 and 35 positive Celsius. That was 110, and then what was it, 120? 5. A common procedure for measuring the velocity of an airstream involves the insertion of an electrically heated wire, called a hot wire anemometer, into the airflow, with the axis of the wire oriented perpendicular to the flow direction. The electrical energy dissipated in the wire is assumed to be transferred to the air by forced convection. Hence, for a prescribed electrical power, the temperature of the wire depends on the convection coefficient, which in turn depends on the velocity of the air. Consider a wire of length L equals 20 millimeters and a diameter capital D equals 0.5 millimeters, for which a calibration of the form capital V equals 6.25 times 10 to the -5th h squared has been determined. The velocity V, capital V, and the convection coefficient, lowercase h, have units of meters per second and watts per meter squared Kelvin, respectively. In an application involving air at a temperature of T sub infinity equals 25 degrees Celsius, the surface temperature of the anemometer is maintained at T sub S equals 75 degrees Celsius with a voltage drop of 5 volts and an electric current of 0.1 amps. What is the velocity of the air? And the last question from this is 1.28. So this is before anything gets difficult. Radiation. An overhead 25-meter long uninsulated industrial steam pipe of 100 millimeter diameter is routed through a building whose walls and air are at 25 degrees Celsius. Pressurized steam maintains a pipe surface temperature of 150 degrees Celsius, and the coefficient associated with natural convection is H equals 10 watts per meter squared Kelvin. The surface emissivity is epsilon. Is it epsilon? Anyways. Equals 0.8. First question, A. What is the rate of heat loss from the steam line? Second question, B. If the steam is generated in a gas-fired boiler operating at an efficiency of nu sub F, or eta? Anyways, equals, need to review the Greek letters, equals 0.90, and natural gas is priced at capital C sub G, equals, that's probably cost of gas anyways, 0.02 per megajoules. What is the annual cost of heat loss from the line? Now, going back up. So I guess I can stop this one, and then I'll start another one that is just the excuse me, I'm sorry, just the chapter reading.